Hi folks, welcome back to 10.4 Plane Curves and Parametric Equations. This is the second video in the lecture series, and today we're going to take a look at some more examples on how to graph from a table. Okay, so we've got some plane curves that we're going to sketch, and let's figure out what they look like. So we have x of t equals 4 cosine t. That means to fill out this first column for x of t, we're going to need to have 4 cosine whatever t value. Then our y of t is our 4 sine t, and that's going to help us fill out the second column. Now, let's go ahead and take a look at our table. So you'll notice that I filled in the first few t values, unit, circle, angles, but let's go ahead and finish filling in the t values. We're going to count all the way until 2 pi, and then we'll take a moment to go in and fill in all of our x and y values. So if I keep counting, I have 0, pi over 3, pi over 6, pi over 3, pi over 2. And then I have 2 pi over 3, I have 5 pi over 6, and I have pi. And then I keep counting, I have 7 pi over 6, I have 4 pi over 3, I have 3 pi over 2, that gets me to that third quadrant, and then I have everything in the fourth quadrant, and 11 pi over 6, and I get back to 2 pi. So if you're working through this video, I would encourage you to pause here, take a moment to fill out the x of t and the y of t, and then come on back, all right? All right, so in looking at these x of t values, all right, hopefully those match up with what you have. You want to make sure that if you're using your calculator that you're typing in radian measures, and then we're just going to round to 2 decimal points because that's probably about as accurate as we can graph points on their graph in just a little bit, okay? Now, when you fill in your y of t values, you should see a similar pattern, similar numbers coming up, but in a slightly different order. Okay. So do a double check, make sure your values match mine. And then I'm just going to circle a few of these to kind of plot, okay? So 4, 0 is where I start. I can plot all of these points. So 3.46, 2, 2, 3.46, and then 4, 0, 4, and then this point, and then this point. Okay. So if we connect all the points that we have, and we start over here, we will notice that we're getting a circle. And in fact, this circle has a radius of 4. Okay? And because I started here and I went in this direction, I want that to be very clear on my graph which direction I'm going in, okay? All right, so this would be a good example of that simple closed curve that we saw way back on the first page, okay? And this is one method that you can use to graph, all right, or to look at what the picture looks like, is to graph it and see, all right? But you can see that this is a lot of points to plug in, and if you don't know your trig values, this could be very tedious, okay? But let's take a look at number 5, which is a different way of figuring out what the equation looks like. So there's a process called eliminate the parameter, and that helps us rewrite our equation in rectangular form or something that's just more familiar to us, okay? So let's write down our equations here. X equals 4 cosine t, and y equals 4 sine t. Now, one of the things that we talked about way back in, I think it was chapter 6 maybe, when we learned about all of the different trig identities, is that one of the most important ones is the Pythagorean identity. So sine squared plus cosine squared equals 1. And this is actually one way that we can use to help us eliminate the parameter. So instead of writing sine t, okay, I'm going to say that sine t equals y over 4. So I just divided that 4 to the other side. And I get y over 4 squared instead of sine t squared. Well, what can I do to isolate the cosine here? To isolate cosine, I can do x divided by 4. And so instead of cosine squared, I can write x over 4 squared, and that equals 1. And now I'm going to go ahead and distribute, and this is going to give me y squared over 16 plus x squared over 16 equals 1. And if you watched our videos, I think it's 10.2, I talk about ellipses and circles. This is actually a circle with a radius of 4. And that is exactly what we have in our diagram above, okay? So we've got using a table, and we've got eliminating the parameter as a second method, okay? So now we're going to practice eliminating the parameters and then sketching our graph afterwards, all right? So let's move on to question number 6. So for questions 6 and 7, we're going to sketch the graph of the curve C that has the given parametrization by eliminating the parameters, okay? I'm asking you to use a different method than we did just using a table. So step 1, we're going to eliminate the parameters using substitution. So I've got two equations here. I've got my x of t equals negative 2 plus t squared. And I've got my y of t equals 1 plus 2t squared. So here's what I'm going to do. I look at both equations first, and then I think, what can I substitute? Is there something that's the same in both equations? And I notice that this one has a t squared, and so does this one. So what I'm going to do is I'm going to take the green equation, and I'm going to get t squared by itself. So x equals negative 2 plus t squared, and then I will get t squared equals x plus 2. And so now what I'm going to do is everywhere that I see this x plus 2, I can put in place of the t squared. So that makes this y equals 1 plus 2 times x plus 2. And if I distribute to get it in a more familiar form, I'll get 1 plus 2x plus 4, or y equals 2x plus 5. And so this is my rectangular form, of my equation, okay? Now I bet we can all look at y equals 2x plus 5 and be like, that's y equals mx plus b, and that is going to be a line, and you would be right. So we're going to go ahead and plot this line that has a y-intercept of 5 and a slope of 2. Okay. Now you might be asking, well, how does she know when to start and stop? Now that's important. That's a really important question. It says here that t is in the real numbers. That means that it kind of goes on forever and ever. And so I need to think about what happens to the numbers as I plug them in, okay? So I'm going to go ahead and connect these points first. Ooh, there we go. Connect all those points, all right? And I'm going to plug in some numbers into the green and pink equations and kind of think about where to start, all right? So let's say I have zeros in there for t. That would give me -2, 1, okay? Now what if I start plugging in bigger numbers? Well, -2 plus 1 is 3, or -2 plus 1 is -1, and then 1 plus 2 is going to give me 3. And so if I keep kind of plugging points in my head to think about the direction, I'll notice that this goes in sort of both directions. Like it goes down this way, but then at some point it turns around and goes back the other way, okay? So it's okay if the points go in one direction and at some point turn around and go back in the other direction. You can simply show both arrows on there to help out with that. All right, so we're going to stop here for video number 2, and then we're going to come back and take a look at a few more examples where we're going to practice eliminating the parameter and drawing the graph. All right, see you back here.